So first of all, huge welcome to, first class of Intro to AI Product Design. So we have like the HCD process that probably some of you may be familiar with, if not all. It's always about like, hey, find a problem and describe it as well as you can, as you understand. Do even more research around it through exercises like context mapping, all the user researchy techniques that kind of exist in the world of sorts, so that then you can start ideating, coming up with ideas and prototypes and just like, huh, what is actually the true problem that our users are kind of having? And so, of course, we have Google Maps. Google Maps is like you click on a place and you get this little side panel, of like the details of sorts where you can get like your directions and ratings and all of that kind of stuff. And I ended up like pulling this a little bit more open and to kind of show you how complex this thing is, how fast it basically it is, but also like all the different models that are kind of powering this little side panel, Um, and so basically when we look at this panel, and this is like me scrolling down a few rows, what do we have? This is like the end of let's say like this use case, just showing how many models all work in like these very natural experiences, but also the complexity that it requires to deliver these. Here are some little differences is when you're looking at, let's say like supervised learning is you need to absolutely have our three splits, train, validate, and test. You just need to have that, which means, hey, here are answers, like question answers of sorts. And here are questions with the answers I'm giving you. And here is the actual exam where I'm just give you the question, but I'm not going to show you the answer. Now, when it comes to like unsupervised learning, basically what we give the model is just a massive train and test set of sorts. Like that little validation thing, we don't even worry about because we don't care about like your final exam. The model will take care of that. And so what it then basically does is like it gives you like, hey, I think these are the cool patterns and stuff like this, that somehow in its mind, the model like it just makes sense mathematically. Here's the example of let's say like the like the ChatGPT one of like giving like being able to rate bad responses, for instance, different ways of giving feedback. And I think I had one more. Yeah, so we talked about the autopilot. Um, so that example where the interesting thing is, as the scale of feedback is becoming so huge for Tesla, one of the items is that right now they actually have a massive data team that is kind of reviewing what the model is starting to learn. And so ultimately, where it all comes back is that whole reinforcement learning story. It's really about you need to give it a massive amount of data. I mean, it's just insane. You need to get like experts, you know, of expert users in a very specific context, like the thing you're trying to solve. And you need to give it a whole mass amount of everything else. What a machine or a system is trying to do is just finding a linear regression, and it's literally like machine learning at its core, at its truest essence, is just like finding regressions between things, finding, let's say, like variables that have somewhat of an impact to each other. And literally have like, if I see this and that, then the ending result is most probably that. The major question that, let's say, like these deep learning engineers that they keep asking is like, hey, is the valley that we have discovered deep enough for our model to be acceptable by business? And if it's not, keep searching, keep throwing more money at it. That's kind of the thing. We can do something fun. We can basically build kind of a deep learning model about picking up, not only doing cats and dogs, but we can do it with 10 different animal species. Now, what is super cool, and this may date me a little bit, but basically in 2016, so deep learning was like exploding of sorts. Google started an initiative called Teachable Machine, and Teachable Machine was a team set up by Google in 2015 or 2016 to really teach absolute novices how these things work. It's an incredible academic thing, like from an educational point, it's wonderful. And we're just going to hit train. And so as we're training, so this is all happening in your browser, which is super cool. So they're like preparing training data, and usually 50 epochs will go pretty fast because these are small images. Don't switch tabs. Okay, yes, yes, yes. We're not leaving. Okay, so you see the training happen. Cool. Um, we're not going to use a camera, but I think for that would be fun for once. Okay, nice. So apparently I look more than a cat than a chicken. That's an interesting thing. It thinks it is nearly always correct. And this also shows something else. So for instance, if we were to add another class, and let's say like this is the Michiel class, I'm going to take my webcam. I don't know if I can do both at the same time. Hold to record. Oh yeah, it's taking images of me. Awesome, awesome, cool. I have a whole bunch of images. I have way more images of me than I have of anything else, and I'm going to train this again. Let's see. And so hopefully next time around, as we train, so it goes pretty fast, is hopefully now you should see that Michiel is now always lit up. And so it's almost like a new set of design principles of sorts. And so what's super interesting is, so when I was at Microsoft, I worked on two things directly related to this. And it's literally this kind of like human machine teaming or human AI experiences. So we actually created an open source, two entire toolkits of sorts, all for one designers and two like business owners of sorts to figure out like, hey, what are the major bits and pieces that we need to make an experience that has some form of machine learning, automation, whatever, actually still one user friendly. And so here are some of the really famous data sets that are currently being used. So Fairface is the one that is kind of the resulting child of all of the other data sets like UTK, LFW, CelebA. Like from these three on the right, you can kind of see like, even if you just squint, you see some kind of a pattern in there of sorts, like you can clearly see that there's something wrong in here, that they're not like real people. Fairface is at this point the only data set for computer vision that is 100% balanced for all gender, color, sizes, people, ethnicities, et cetera, et cetera, et cetera. And so that means like when you're kind of zooming out in terms of like, hey, where does bias kind of get in like a model? It's like at the earliest stage is when data gets collected. The next piece of bias is when data gets processed of sorts. It's like this is like where hey, how are we going to stratify our data set in a sense of like, what are we going to keep? What are we going to throw out? Like, what are those kind of things so that a data set is really like nicely balanced to some extent? And then, of course, there's bias when the model gets developed. Like, what kind of architecture are we going to use? What kind of things are we going to use? Because who knows what that might impact. In addition, whenever a model gets deployed. So in a sense, like, there's no more training happening here, but it's really like real world application of the model that just somehow, favors some people over others. Thank you all so much. Have a great evening, and I shall see you guys in a couple of days.